This is day 3 of Unit 4, Section 1. We are going to be doing textbook section 7.3, the first half. So we're going to start by factoring. So factoring is something we've been doing for a long time now. So just to refresh our memory on some of the different kinds, right? If it's 3 terms and it's squared, we're going to look for what multiplies to C and adds to B. So what multiplies to 12 and adds to 8 are 6 and 2. So this factors to x plus 6 and x plus 2. Same thing for B. I want to multiply to negative 20 and add to negative 1. So that's a negative 5 and a positive 4. C here is a little different. This was a cubed minus b cubed. And that was one of our special patterns that we had to plug into a formula. So that was going to be a minus b, and then a squared plus ab plus b squared. So I have to figure out what the two things are that are being cubed. In the first spot, it's x. And in the second spot, the cube root of 8 is 2. Right? We ignore the signs because the signs are going to come in here. So this factors to x minus 2, and then x squared plus 2 times x plus 2 squared. So I'm going to write it as 4. I'm not going to leave it as 2 squared. I'm going to turn it into 4. And then D, we have a number in front. So our first step changes compared to A and B up here. We're going to do 5 times 12 first and get 60. And now we're going to find the things that multiply to 60 that add to B of 32. Right? So 1 and 60, 2 and 30. 2 and 30 adds to 32. Those are our numbers. So here's where we could either do it by grouping, where we write 5x squared plus 2x plus 30x plus 12 and factor by grouping, or take ax and put it over each number. So 5x over 2 and 5x over 30. 5x over 2 doesn't reduce, so it's going to stay 5x plus 2. These both divide by 5. So this is going to be 1x plus 6, or just x plus 6. All right, so we're going to need to be able to factor to do our lesson today. So here we're talking about multiplying and dividing rational expressions. Today we're going to focus just on simplifying before we get into multiplying and dividing. But a rational expression is any fraction whose numerator and denominator are polynomials. And the simplified form is when the numerator and denominator have no common factors besides 1. So they're as low as they can go. They're in their factored form usually, and we cannot divide anything else out. So as long as I have multiplication, 2 terms being multiplied, either single letters or an actual expression, as long as they match, I can cancel them out. So if I had 15 over 65, 15 can be rewritten as 3 times 5, and 65 can be rewritten as 13 times 5. So the 5s would cancel, and I'm left with 3 over 13. Whereas here, if I had 4 times x plus 3, all over x plus 3 times x plus 3, a set of x plus 3 is canceled, and I'm left with 4 over x plus 3. Once it's down to something like this, x plus 3 is an entire term itself, so you can't cancel out any part of this with something that was left above. So that means if I had something like 6 over x plus 3, I don't get to reduce the 6 and 3. This is one whole part by itself, and as long as there's no matching whole part to it, it stays exactly as it was. So let's start with just some basic exponents. So we have x to the 5th times y to the 3rd over x squared times y to the 7th. So x to the 5th is really x to the 3rd times x squared, right? And the bottom is x squared. And then the top is y to the 3rd, and the bottom is really y to the 3rd times y to the 4th. So the y to the 3rds would cancel, the x squareds would cancel, and I'm left with x cubed over y to the 4th. Right? There's another way to look at it. We could do 5 minus 2 and get 3, 7 minus 3 and get 4, right? That's a simpler way, but if we're talking about being able to cancel out factors, it's easier to look at it like this. All right? Product is the same as simplify, it's just that we get one big top. So this I could pretend, and this I could pretend, and I could join these as well. So it might help to get one new top and one new bottom before we start to cancel things out. So a times 7 was 56. X cubed times x to the 4th is x to the 7th. and y to the first times y to the third is y to the fourth. And I have 2 times 4 on the bottom is 8. X with nothing to multiply is just x, and then y squared times y to the first is y to the third. So 56 is really 8 times 7. X to the 7th is really x to the first times x to the 6th. And y to the 4th is really y to the 3rd times y to the 1. And on the bottom we have 8 times x times y to the 3rd. I chose these numbers up here because I was looking at the bottom, right? I knew 7 was here and 1 was here, so I broke this down so I'd have a 1 in it. I knew 3 was here, so I broke the 4 down so I'd have a 3 in it. And now let's start to cancel. 8 cancels with 8, x1 with x to 1, y to the 3rd plus y to the 3rd. So I'm left with nothing on the bottom, but the top is now 7, x to the 6th, y. Let's look at the same thing for b. 3 times 6 is 18. X to the 5th times x to the 1st is x to the 6th. And y to the 2nd times y to the 2nd is y to the 4th. 8 times 9 is 72. X to the 1st times x to the 3rd is x to the 4th. And y to the 1st times y to the 1st is y squared. So I have an x to the 4th on the bottom, that's bigger. I have a y squared on the bottom, that's bigger. So when I go to write the top, I'm going to write it with an x to the 4th, which is then times x squared. And that y to the 4th is really going to be y squared times y squared. Right? So on the bottom we had x to the 4th and y squared. And 72 is really 18 times 4. So now when we cancel 18 with 18, x to the 4th with x to the 4th, y squared with y squared. So on the top I'm left with x squared times y squared. And on the bottom, I'm just left with 4. All right, you go ahead and try these two, pause it, and then I will show the answer. All right, check your answers there as we move on. So here we have a rational expression that we want to simplify. So it's already factored for us, which is fantastic. So I'm just looking to see if I have any factors in common. So there's an entire x plus 1 on the top, and there's an entire x plus 1 on the bottom. So those can cancel with each other, and I'm left with x plus 5 over x plus 3. I don't have any entire x plus 5 on the bottom. I don't have any entire x plus 3 on the top, so nothing else cancels. I can't touch the x's. I can't touch the numbers. This is our answer. All right, very rarely will they be set up for us that way, though, so we're going to have to factor them first. So I'm going to factor the top. So multiplies to negative 12, adds to negative 4 is x minus 6, x plus 2. Factor the bottom, that's the difference of perfect squares, right? A squared minus b squared, which is a plus b, a minus b. So that's x and 2, so that's x plus 2, x minus 2. So now I'm going to look at this, and I have an entire x plus 2 on the top and on the bottom. I don't have any other x minus 6's. I don't have any other x minus 2's. So my answer is x minus 6 over x minus 2. And I'm done with that problem. Let's look at b. Multiplies to negative 3, adds to negative 2 is x minus 3, x plus 1. And on the bottom, multiplies to negative 6, adds to negative 1, x minus 3, x plus 2. So here, I have an x minus 3 to cancel with an x minus 3, and I'm left with x plus 1 over x plus 2. And that is my final answer. Remember, can't touch the x's, can't touch the numbers, because they're both part of something bigger. All right, let's continue here. Multiplies to positive 12, adds to negative 7 is going to be x minus 3, x minus 4. And now this is just like the one we did before. That's a cubed minus b cubed. So a is x, and b is going to be 3. The cube root of 27 is 3. So the bottom is going to be x minus 3, x squared plus 3x plus 9. So I have x minus 3's to cancel. I'm left with x minus 4 on top. and then x squared plus 3x plus 9 on the bottom. Can't do anything else to either of them, so that's done. And the last one we'll do together here, I actually just have a GCF here. I have an x squared plus 9x, so they have x in common. And when I take the x out, I'm left with x plus 9. So the bottom, x squared, I could really write as x times x. So when I go to cancel things, this x cancels with this x, and I'm left with x plus 9 over x. Again, x plus 9 is an entire term. If there's not another x plus 9, I can't cancel any part of it. So that's it. That's my answer. You guys try these too. You can pause it, and I will show the answer. All right, let's check over our answers here. So number 3, I have my factored form first, and then my x minus 6 is canceled, so I was left with x plus 3 over x minus 1. For 4, the bottom was one of the special patterns. So for a cubed plus b cubed, it's a plus b times a squared minus ab plus b squared. So that ends up as x plus 2 times x squared minus 2x plus 4. So the x plus 2's cancel, and I'm left with x plus 9 over x squared minus 2x plus 4. All right, we're just going to keep practicing, but now we're going to have some that have a is greater than 1. So that means the factoring is just going to take a little longer. So if I want to factor this top, I'm going to do 7 times negative 15. And I get negative 105. So negative 105, we're going to find a positive and a negative because it multiplies to a negative. So I could do 1 and negative 1 and 105. 2 doesn't go in. Negative 3 and 35. And looks like that is the magical pair that's going to add to 32. So we're going to take 7x over negative 3 and 7x over 35. This part doesn't reduce, so it's going to stay 7x minus 3. This part, right, we can divide by 7. So I'm left with 1x and a positive 5, or x plus 5. And in the denominator, I just have a GCF, right? What's in common between 2x and 10? That's a 2. And I could take out x plus 5 there. So now looking at this, my x plus 5's cancel, and I'm left with 7x minus 3 over 2. Okay? So b is going to be the same thing. Come on. There we go. But now both the top and the bottom have a number in front of the x squared. So let's do the top first. 3 times 12 is 36. Right? 36. We're looking for a negative, so it's going to be negative, negative. Negative 1, negative 36. Negative 2, negative 18. Negative 3, negative 12. Negative 4, negative 9. And that looks like the pair that's going to add to negative 13. So we're going to get 3x over negative 4 and 3x over negative 9. 3 and negative 4 don't cancel, so we're left with 3x minus 4. And this we divide by 3, so we're left with 1 over negative 3, 1x minus 3. As for the bottom, we'll do 7 times 9, 63. We add to negative 24, so again, we're going to get negative, negative. So negative 1, negative 63, 2 doesn't go in, negative 3, negative 21. That's our pair. So we're going to do 7x over negative 3 and 7x over negative 21. So this doesn't reduce, so we're going to keep 7x minus 3. And this divides by 7, so 1 over negative 3, or x minus 3. So here our x minus 3's will cancel, and I'm left with 3x minus 4 over 7x minus 3. All right, you go ahead and try the last two, pause it, and I will show the answers. All right, so for number 5, the top factored to 5x plus 6 times x minus 9. The bottom had a GCF of 5x, and when we took that out, we were left with x minus 9. So the x minus 9's canceled, and we were left with 5x plus 6 over 5x. I will stress it again. I will stress it every time we have this problem. Even though there's a 5x on the top and bottom, this is not 5x. This is 5x plus 6. So there's nothing to cancel. Those 5x's can't be touched. This is the final answer. For 6, the top factor to 5x plus 3 times x minus 10. The bottom to x minus 10 times 7x plus 8. So the x minus 10's canceled. I'm left with 5x plus 3 over 7x plus 8. And that is the end of the first day of section 7.3.